This series of videos is intended to provide a framework for applied statistics. There's a distinct difference between talking about applied statistics and the more commonly taught academic statistical approaches. So I'm going to call this my framework for applied statistics because I'm trying to help people who are going to go into a regular job site, usually with just a bachelor's degree or some other training, and they're going to need to use statistical work in an applied setting, and they're not going to be trying to answer the questions of the universe. They're not going to be trying to make sense of great conceptual theoretical issues. They're not going to be testing theory. They're not going to be building theory. They're going to be basically trying to answer straightforward questions in a particular context at a for-profit or a not-for-profit, at an agency, at a church, at any situation where they're just simply saying, I have a little bit of data, I need to run some analysis, I want to make sense of what patterns I'm seeing so I can answer questions right now about how satisfied my clients are, how well the program is working, those kinds of questions. So a framework for applied statistics. Now, every video in this series, I'm going to quickly revisit this framework at the beginning and then go into particular tools that will help you to answer specific kinds of questions. But here, I want to summarize what the framework entails in whole. I need to first say that the framework doesn't do some things. This series of videos assumes some pre-existing knowledge. If this is your first exposure to statistical analysis, then this isn't going to answer all of the questions. In fact, I'll point out a little bit of that in some of the slides to come. But you'll probably need to do some other Google searching, some other reading, get a basic stats book to figure out certain key things that these videos won't help you do, because these are just about nuts and bolts. How do you answer a question in a real setting right now? A couple of ways that you can go wrong in using this kind of statistical technician approach that I'm providing here. You're not going to be a professional statistician by any stretch when you're done with these videos, but you're going to be a statistical technician, and you're going to be able to do the work in an applied setting in a pretty straightforward way. But there are a couple of risks you run. One is that you may use a tool where it shouldn't be used. Every tool is only useful in a certain context. We have assumptions about when it's appropriate. The tool, in fact, was built to work in a certain circumstance. So you could have a tool like a shovel that isn't much use to you when you're cooking in the kitchen. And you could have a tool like a whisk that isn't much use to you when you're trying to build a house. There's a context for every statistical tool. There are assumptions about what is true in the data, what is true in the context for that tool to be used. I'll mention most of the key assumptions when I go through these videos, but you may need to go look some stuff up. So if I talk about homoscedasticity, you'll say Gesundheit, and then you'll need to go look up what it means to have equal variance across different categories of the independent variable. If you don't, you're probably all right if you're working with straightforward data that's of a common form, but there is a chance that you will in fact misuse a tool. Another place where you can go wrong is you won't understand the mathematical choices that were made in the building of these statistical tools. Most of us think of math, those of us who haven't had a lot of experience with math, well, I've had a lot of experience with math, but those who haven't had a lot of experience with math tend to think of it in terms of maybe the four basic operators: adding, subtracting, dividing, multiplying. And they think algebra is basically just an extension of those, but algebra's not. Algebra is in fact a modeling of certain patterns. When you build an equation, when you do simultaneous equations, when you do a number of things in algebra, you're actually going beyond just the use of the operators. When you move on to probability mathematics, which is at the basis of the kinds of statistical tools we're going to look at here, we're going to be looking at the basic statistical tools usually taught in an intro to stats class. They're sometimes called the frequentist statistics as compared to some other entirely different mathematical ways of approaching things. And these different tools, they were built. There isn't really a 1 + 1 = 2 logic to the mathematics involved in a lot of these tools. There were decisions made about how do we mathematically accomplish a task. So for example, there's a common use of deviation from something in statistics, where you say, how far is one number from another? And we all say, subtraction. Yes, how far is one number from another? And we think in terms of that basic operator. But then they take that subtraction and they square it when they could have done an absolute value, when they could have done a number of things. And they made that choice because they're trying to accomplish a particular task with the tool. So not knowing the assumptions, not knowing the mathematics can, in fact, cause you to do something wrong. But I believe for most people who are just working with some basic data they've collected from their clients, or some basic data they have about sales in their organization, or some basic data they have comparing the counties of a state on teenage birth rates or something, I think most of that data, you're going to be fine to just go ahead and use the statistical tools as a technician. You can drive a car without understanding how it works. You can use statistics without understanding how they work. But when you find yourself in an unusual circumstance, your lack of knowledge of how they work can in fact cause you some difficulty. So with that caveat, with that warning, I want to say that I think that this framework for applied statistics can be very helpful for most people in basic data analysis situations. All right. Now, here's a 3-item outline of the framework. This is a framework that first helps you to figure out how to choose a statistical tool that you're using. And then second, helps you to identify the actual statistical results that you need to be looking at to answer a question. And third, uses those results in a particular way to correctly answer the question that you posed. Now, this is not the same, answering questions, as hypothesis testing. And for people who watch this series of videos, who learned in an academic stats class how to do hypothesis testing, which fundamentally focuses on just doing a narrow kind of analysis, just focuses on statistical inferential significance, they will know those terms. Those people may be frustrated with this. But having done a lot of applied work in a lot of settings, hypothesis testing is an incredibly valuable way to approach statistics, but it's incredibly limited to the person in an applied setting who needs to make a decision about whether they increase the funding for program A or program B. It's not just a matter of significance, as we'll see in some later videos. So let's expand those 3 things and say what's under each of them. Well, for choosing tools, we need to understand levels of measurement, and we need to understand a particular way of identifying kinds of analyses. And I'm going to use that phrase in a very specific way. I'm going to explain in a moment, and it could mean almost anything to anyone, so I'll have to explain that one more. For identifying the right results, I'm going to simplify statistical tools down to ones that accomplish one of 4 different tasks. There are basically 4 things we try to do with statistics. And then to use the results to answer the questions, I'm going to posit that there are basically 5 things you need to do to correctly use the results to answer questions. Let's unpack each of those really quickly. I'm not going to explain levels of measurement. There are a lot of sources that can help you understand levels of measurement, but we all know that we can measure something, how educated someone is, how happy someone is. We can measure these things with more or less precision. We can measure it in different ways. Well, there are these categorical ways that put everybody into discrete categories that are either nominal or ordinal. And there are scaled measurements that put people into what would be called interval or ratio. That's just something that if you don't understand levels of measurement, we're done. You're going to have to go and find out some basic information about levels of measurement to be able to use this framework. But at the least, you need to be able to tell when a measure is categorical, it puts the cases into discrete categories, you're a male or a female, you agreed or you disagreed. As compared to a scale measurement, your GPA is on a scale from 0 to 4, or your income is counted out in dollars from $0 to whatever the upper limit might be. So levels of measurement is the first thing you would need to know. And then I'm going to say kinds of analyses basically means when you're trying to answer your question, are you going to do an analysis of a single variable? I don't want to see if anything's related to something else. I just want to see the pattern. So I have 5 questions that ask how satisfied people are with the service that I provide. And I look at the first question and I find out how satisfied they said they were. And then I separately look at the second question, separately look at the third. I'm just doing a series of 1 variable analyses. Alternatively, I could be doing a 2 variable analysis. And so I could say, on that first question about how satisfied they are with the service I provide, do men and women give different answers? Now I'm looking at one pattern, male or female, and I'm trying to see if that pattern is related to some other pattern, how satisfied they are. And we would call this the predictor variable and the outcome variable, or we might call it the independent variable and the dependent variable if we're making a greater claim that in fact these two things are related causally. All right. Again, most of this you would need to have more understanding to use this framework, but I'm thinking most people who are using these videos have already had familiarity with these things and are just looking for a way to quickly remember how to use some tools. Third, we could be doing multivariable analyses, which basically use predictors and outcomes, or independent and dependent variables, and also statistically controls for other factors. All right. If I put those two things together, I can say the dependent variable that I'm using for my question, is it categorical or is it scaled? And I can put it in one or another column. And then I could put my question into a row by saying, am I going to need to do a 1 variable analysis or many 1 variable analyses? Am I going to have predictors and outcomes, 2 variable analyses, or am I going to want to do predictors, outcomes, and controls, simple multivariate analyses? And what we find is when we go to choose tools, if we have categorical dependent variables, then if you're doing 1 variable analyses, you will almost always simply use distributions. More on that in a video to come. If you're doing, you have a dependent variable categorical analysis, categorical variable, and you're doing 2 variable analyses, then you will almost always use cross tabulations. And if you're doing a simple multivariate analysis with a categorical dependent variable, you'll almost always end up using controlled cross tabulations. If you have a scaled dependent variable, then for 1 variable analyses, you'll almost always use a central tendency measure, usually the mean, and a measure of dispersion, usually the standard deviation. More on that to come. And then there are 2 different ways you might do 2 variable analyses and 2 different ways that you might do simple multivariate analyses. But this gives us a grid, a very simplified grid, that 90% of the time, this is the tool that will answer the question that you're working with. And I'm going to build videos that look at each of these tools. But if we go to step 2 and we want to identify, we run those results. We say, oh, I need to run a cross tabulation. So I go and I run a cross tabulation. And I'm going to do a video that will show how to run a basic cross tabulation in a free statistical analysis software. Then how do I know what numbers I use from those results to actually answer my question? Well, to do that, we first have to recognize that there are 4 things we can do with statistics. We can try to see if there are trends in the data or if there are variations. A simple example of this would be if we ask people if they're satisfied with the service that my organization provides, and 95% say they're satisfied, then there's a very strong trend. But if we have 20% who say they're strongly dissatisfied, 20% who say they're dissatisfied, 20% who say they're on the fence, 20% who say they're satisfied, and 20% who say they're strongly satisfied, it's all variation. There's no trend. An equal number of people chose every answer, and there's no clear trend in their answers, they're spread across everything. So trend and variation. Here's another example. If I find that men tended to be very satisfied and women tended to be very dissatisfied, then I have a trend. But if men and women have the same answers, men, whether they're satisfied or dissatisfied, had the same percentage distribution as women do, then there is no trend amongst men and women in their satisfaction. There's a lot of variation. Okay, strength is an ability to see when there's more trend. Certain statistical tools actually help us to predict patterns by seeing trends. So it may do it in a variety of different ways mathematically, but as we have an ability to say, most people were satisfied, so I'm going to predict that the people walking in the room who are my clients, that they are satisfied, because 90% of the people said they were satisfied, hypothetically. But if there's not much trend, then I can't predict things very well, and the statistical tools of strength will say, well, then we don't have much strength in our patterns. Significance, statistical significance, is the hallmark of hypothesis testing analyses, and it's very valuable, but it really only does one thing. And sometimes people get caught up in the almost magical obsession with saying something is statistically significant. All it means when something is statistically significant is that we can reject the claim that there's no trend. So if we found that men and women had different views of their satisfaction, then we might find that there was enough trend there, men had enough different view than women, that we could reject the claim that there's no trend. That's really what statistical significance does. The null hypothesis is basically a claim of no trend. And so statistical significance is valuable. We'll look at it through all the tools we're going to work on, but when appropriate, we'll look at it. But by itself, it doesn't actually answer your practical applied questions. It just adds one more piece of information to help you make decisions about what you've learned. And then there's specification, which is the far more complicated piece of this. If we're trying to do something more academic in our analysis, we do a lot of this, where we try to figure out how all the variables relate to each other, which ones affect which other ones, and in what ways, and in what chains of effect. That's specifying where all the variables belong relative to each other, and that's something that certain statistical tools do. So those are the four things you can do with statistics. Now, if we go back and we line that up with the kinds of analysis, we find that if you're doing one variable analyses by custom, and because some of the things aren't possible, you basically just describe trend and variation. If you're doing two variable analyses, you look for shape, strength, and significance. And if you're doing simple multivariate analyses, you do shape, strength, significance, and specification. So as I work through the videos in the future that look at each of the different tools, I will look at these specific things with any given tool. If it's a two variable analysis tool, a comparison of means, then I will say we need to look at the shape and the strength and the significance to be able to figure out what results matter here. We can't just look at significance or just look at shape or just look at strength. We need to look at all three of those things to be able to answer our question. So if I put this on my grid, one variable analyses are going to look for statistical tools that describe the shape. Two variable analyses are going to look for statistical tools that do shape, strength, and significance. Simple multivariate analyses are going to do all four of those four things. And so I end up with distributions just talking about shape. Cross tabulations do shape, strength, and significance. Controlled cross tabulations do shape, strength, significance, and specification. Similarly, central tendency and dispersion measures are about shape. Comparison of means is about shape, strength, and significance. Factorial ANOVA is about shape, strength, significance, and specification. Similarly, correlation, shape, strength, significance, regression, and here I mean multivariate regression, looks at shape, strength, significance, and specification. So this framework, this grid, tells me which tools to use to answer a practical question, and tells me what kinds of results I need to be looking for to be able to answer my question. But then, when I have the results, how do I answer the question? Well, based on my own experience and what's broadly understood in a variety of different literatures and a variety of different circumstances, I would argue that I think there are 5 guidelines. And I'm going to work through these in the examples. You'll see for each tool how I use this. But first, don't just look at the numbers and think that you have an answer. You need to see patterns. And to see patterns in the number, then you need to be able to describe it in words. You can't really answer your practical questions unless you can describe what the statistics are telling you in words. So you describe the patterns in words. And then you provide those statistical results as the evidence to justify your claim that's made in words. You need to stay true to your cases. We'll see examples of that, but if you're studying the results from a variety of clients who are talking about their satisfaction, then you need to be clear that you're only talking about clients. You can't compare stores to each other. You can't compare agencies to it. You can only compare the people to each other because that's the data you have. So you have to stay true to your cases. You have to stay true to your measures. You have to remember what is actually measured. If I ask a question about people's satisfaction and then I draw conclusions about how happy they are or whether they enjoyed working with the staff, those weren't the things that were asked. And now I've moved beyond the measures that I actually have data on. So stay true to the measures we'll talk about. And then when we do want to make interpretations, why might these answers be the form they are? Why did people give these answers? What else might be involved here? All of that speculation is incredibly valuable, might be exactly what you need to be doing, but you want to make sure you don't confuse it with the actual empirical description. So if I find that 90% of the people are satisfied, and then I say, I think that's because our staff do such a good job working with them, now I'm interpreting what might be causing the pattern. I'm not describing the pattern. Keep those interpretations about what might cause patterns or what might come from patterns or why patterns exist. Keep those interpretations separate from your empirical observations based in the actual data. So I end up with a framework where I can choose the right tools, I can locate the right results, and I can report those results in a way that answers questions practically. So this is my framework for applied statistics. If you're looking for a way to do basic analysis that answers immediate questions in real-world settings, then this framework might be the way forward for you. I will take this framework and I will apply it now to distributions, cross-tabulations, controlled crosstabs, and the other tools listed in the grid. Hopefully, this approach will provide you with a way to be an effective statistical technician. You'll recognize that there are limits to what you can really do, and you'll know that you're going to have to continue to look for additional information elsewhere to flesh out some of the materials that I'm assuming you know when you use this framework, but it should be able to help you to make practical decisions and provide practical answers in real-world settings.